Today's notes are on 6.2, part 1, volumes. And this is going to be the disc method and the washer method. I'm going to introduce some types of volumes. Let's say we had a solid like this. This is the base 1. This is the base 2. This is going to be your height. Now this right here is going to be a cylinder. Now the volume for a cylinder is the area of the bottom times the height. So this is going to be the area of the base, and that's going to be the height. Let's say we had a circular cylinder, like a can. This is our height. The bottom is a circle with a radius of r. The volume is once again going to be the area of the base times the height. But this one, I know the area of the base. That's a circle, which is going to be pi r squared times the height. Next, we're going to have a rectangular box. Here's our height, our length, and our width. So the volume, once again, is going to be the area of the base times the height, which in this case, the area of the base is the length times the width times the height. A disc is going to be a solid. A washer is like with a hole in the middle. So you want this region right here. Almost like a donut or a washer. Now the volume here is going to be pi times the radius square, which that's my radius. The volume here is going to be pi, and it's going to be the big radius square, subtract the small radius square. Now this is going to work for all types of these. If we have a horizontal, this is a dx type problem. The volume is always going to be, now because it's a dx problem, my upper bound and my lower bound are going to be x's. It's going to be the large radius, subtract the axis of revolution, square, subtract the small radius, subtract the axis of revolution, square dx. If we have a vertical, so this is a dx type problem, this is going to be a dy type problem. The volume here is going to be pi, and these are going to be in y, so I'll say y equals c and y equals d. Your upper and your lower bound have to be in reference to the y values. And it's going to be the large radius, subtract the axis of revolution, square, subtract the small radius, subtract axis of revolution. And this is a dy type problem. Now, we must choose a rectangular strip perpendicular to the axis of revolution. So let's see what these look like. So if we have a graph like this, here's A to B, and it looks like this. So this one is going to be a horizontal axis of revolution. So I don't know if you guys can picture this. It's going to rotate around like this. So this is going to be a horizontal axis of revolution. So right here, what's happening is this is going to be my axis of revolution, and it's rotating like this. Now this is going to be the graph right there. And this is a dx problem because it's perpendicular to the axis of revolution. So the volume here is going to be pi, and this is a solid from A to B of whatever the radius is, square dx. Now this one here, I'm going to show you a vertical. Now a vertical one would look like this. So here's my axis of revolution, and I'm rotating it like this. Here's my graph. And remember that it's perpendicular to the axis of revolution. So this is perpendicular to the axis of revolution. This is going to be your dy. And the volume here is going to be pi from C to D, from C to D of the big radius, and this is y, square dy. So this is the axis of revolution of the x-axis. And this is axis of revolution is the y-axis. Okay, let's get into some examples. I'm going to keep referring back to this. So given y equals the square root of x, y equals 0, and x equals 9, is the region R. Find the volume found by revolving R, which is the region around the, now I'm going to do the same graph, but I'm going to change the axis of revolution. I will be changing the axis of revolution. So let's see, on the first one, we're going to do the x-axis. So the axis of revolution is going to be the x-axis. So this is going to be a dx type problem because you're revolving it around the x-axis like this. Now I want to graph a y is 0 and x is 9. So y is 0, x is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the x is 9 right here. This is the y is 0. And then square root of x, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So keep in mind, we also had y is 0. So this is a solid that you are going to start doing the volume of. So basically, I'm going to revolve it around the x-axis. So this is the x-axis. So that's the axis of revolution. And that happens to be y equals 0. So when we're doing our formula here on the axis of revolution, that's just going to be a 0 there. This is going to be a dx type problem. Now this is going to be known as a disk because as it's revolving, there's no hole in the middle. There's no hole in the middle. So the volume here, everything is going to revolve around the x-axis. So I'm going to do pi. The x is going from 0 to 9. And now the big radius is going to be the square root of x. And then it's going to be minus 0 here. So this is the large radius. That is the axis of revolution. If you guys know it's 0, you don't even need to put 0. Because remember, it's going to be the radius minus axis of revolution and then a square on the outside. I don't have to worry about 2 of them because I only have 1 radius. So then this is going to be a pi from 0 to 9. The square root of x squared is just going to be an x. Let's take the antiderivative now. Don't forget the pi. The antiderivative. I'm going to plug in my upper bound. Subtract my lower bound. That just comes out to be a 0. And the answer comes out to be an 81 pi over 2. I'm now going to revolve it around the line y equals negative 2. So y equals negative 2 is going to be down here now. So it's still going to be this solid. So I'm still going to draw the solid. So this is the y equals square root of x. This is the line y equals 0. And this is the line x equals 9. So this is the area that you are revolving. But now we're going to revolve it around the y equals negative 2 line. So here's negative 1, here's negative 2. So this is going to be your axis of revolution. So now here, what's going to end up happening is this solid, it's going to go around. And now here you have, this is going to be known as a washer. Because I have a hole in between. I have a hole in between. And this is still going to be a dx problem. Because remember, it's going to be perpendicular to the axis of rotation. Now, what I need you to realize is if this is the axis of rotation, this is going to be the big radius right here. Okay, so that's going to be the large radius. And then right here is going to be the small radius. So the small radius is going to have the line y equals 0, but the large radius is going to have the line y equals square root of x. So small radius is going to have a radius of y equals 0. Large radius is going to have the equation y equals square root of x. And the axis of rotation is the y equals -2. So this is a dx problem. This is the formula I'm going to use right here. I'm going to use this formula right there. So it's going to go large radius minus axis of revolution, which is a -2, minus whatever the small radius is, subtract the axis of revolution, which is a -2. And it's going still from 0 to 9. So it's pi from 0 to 9. And it's going to be the large radius. The large radius is this one. Square root of x, subtract the axis of revolution, which is a -2 square. So this right here is the large radius. And this -2 is the axis of revolution. Subtract. Now I need the small radius. The small radius has the line y equals 0. Subtract the axis of revolution, which is y equals -2. And then right here, I can't forget the dx. Now I'm going to simplify this. That's just going to be a plus. And then right here, a negative and negative makes that a +2, and 2 squares 4. When I square this out, square root of x times square root of x is just x. And then when I multiply the square root of x into 2, that's going to actually be a 4 square root of x. And then 2 times 2 is 4. Those cancel out. So that's what I'm taking the antiderivative of. So that's going to be x to the 1/2. So let's take the antiderivative here. Antiderivative of x plus 4. Antiderivative of x to the 1/2. I'm going to add 1 to the exponent, and whatever the exponent is, I'm going to divide by it, which the 2 is going to flip to the top, so it's going to be an 8 in the numerator. And I'm evaluating from 0 to 9. Now I don't have to plug in 0 because I know that's going to give me a 0. And when I plug in the 9, 9 squared divided by 2 plus 8 times 9 to the 3/2 divided by 3, that's actually 112.5. And then I can't forget the pi. Now let's take that same graph, and this time I'm going to move the axis of revolution. So this was the axis of revolution of -2. Let's do an axis of revolution of the line y equals 3. So I need the square root of x graph. Square root of 0, 0, 1, 2, 9. So this is the graph of y equals square root of x. This is the line y equals 0. And this is the line x equals 9. So this is still the solid right here that we're talking about. But now the axis of revolution is going to be y equals 3. So here's y equals 3. And we're revolving it like this. So as you can see here, it's going to be like a cone cut out. So this is the axis of revolution, y equals 3. So the solid's going to be on this side, and as it's rotating around, it's going to look like this. Now, if this is the axis of revolution, this is going to be a radius, and this is going to be a radius. Because this is the axis of revolution. This one is going to be the small. This one's going to be the large. And this is the line y equals 0 right here. So once again, we are using this formula, pi, large radius minus axis of revolution, square. And our axis of revolution in this case is going to be y equals 3. So the volume is going to be pi, and it's still going to go 0 to 9. Now the large radius is this one, and that is the line y equals 0. Subtract axis of revolution. The axis of revolution is the number 3. So that's the large radius. That's the axis of revolution. Next, minus. Now the small radius is right here, and that's the graph of square root of x. Minus axis of revolution is 3. And this is a dx problem. It's perpendicular to the axis of revolution. The perpendicular is up here. So now let's go ahead and simplify that. Negative 3 squared is going to be a positive 9. And then here, I'm going to need to square this out. And when I square this out, I end up getting an x minus square root of x plus 9. I'm going to distribute the negative. And I get the 9's cancel out. That's going to be a negative x. And a negative negative makes that a positive 6x to the 1/2. Take the antiderivative here. That's going to be divided by 3 halves, 2 flips to the top. That's 12 divided by 3, which is going to be a 4. You know, 0 is not going to give you anything. So the answer is going to come out to be a 67.5 pi. This one was a washer because there was a hole in the middle. Okay, we're going to take another region now. Now, as we take this other region, we have the y equals square root of x, and we have a 1/2 x. I'm going to have an A, B, a C, and a D. We're going to change the axis of revolution. On A, we'll just do the x-axis. So to see what these graphs look like, the square root of x, let's see, 1, 2, 3, 4. Hopefully we don't have to go any further. So the square root of x is going to look like this. One half x looks like this, up 1 over 2, up 1 over 2. So it's talking about this region right here. And the axis of revolution is going to be the x-axis on this one. Which happens to be the line y equals 0. So as you're rotating it, here's the curve, the straight line. This is what it's going to look like. You're going to have two radiuses here. This one is the big one. So the large one is going to be the square root of x. The small one is going to be the 1/2 x. So this is the large, this is the small. This is a dx problem because it's perpendicular to the axis of revolution. This is going from 0 to 4. It's going to be the large radius. The large radius is the upper curve, and that's the square root of x. Subtract the axis of revolution, square, minus the small radius. The small radius is the line 1/2 x. Subtract axis of revolution, which is y0, square. Right here, the square root of x minus 0 is the square root of x. The square root of x squared is just going to be an x. Right here, that's going to be a 1/2 x squared. So 1 squared is going to be 1, 2 squared is going to be 4. When I take the antiderivative, that means a 3 is going to go on the bottom, so that's going to be a 12. I'm just going to end up plugging in the 4 because 0 is going to give me 0. 4 squared is 16, divided by 2 is 8. When I do all this, it's going to be 8 over 3. Okay, I'm going to still use the same graph, but this time I'm going to revolve it around the y-axis. So we have the graph of square root of x. And we have the graph of 1/2 x. And now your axis of revolution is the y-axis. And because it's perpendicular to the axis of revolution, this is actually going to be a dy problem. Where if this is axis of revolution, that's going to be the big radius right there. That's going to be the small one. So the big one is now actually the line, y is 1/2, and the small one is going to be the square root of x. So this is going to be the large, this is going to be the small. And this is a dy problem. What that means is everything needs to be in terms of y. So I actually need to solve this and get x equals. So if I square both sides, this one is the same as saying x equals y squared. And right here, I'm going to multiply by 2. So this is the same as saying, if I'm multiplying by 2, I get x equals 2y. So those are the equations I'm going to be plugging in, are these ones. And my y-axis is going from 0 to 2. So the volume is going to be pi from 0 to 2. The large radius is the linear line, which is 2y. Subtract the axis of revolution. Now the axis of revolution is x equals 0. So it's just going to be a 0 square. Subtract the small radius is this curve, which is y squared. Subtract axis of revolution, which is a 0. Two y squared is going to give me a 4y squared. 2y squared square is going to be a y to the 4th power. Antiderivative. And that's going to give me a 64 over 15 pi. Second to the last one. We're now going to revolve it around the x equals 9 line. One, two, three, four, five, 6, 7, 8, 9. The square root of x looks like this. One half x looks like this. So here's the region. Here is the x equals 9 line. This is the axis of revolution. Once again, we want a line perpendicular to the axis of revolution. So perpendicular makes it like this. So this is going to be the small, because that's the first line I hit. And the large is going to be the curve. Perpendicular makes this a dy type problem. So since it's a dy, I need everything in terms of y again. So I don't want y equals square root of x. That's going to be x equals y squared. And I don't want 1/2 x. That's going to be x equals 2y. Now the axis of revolution is the line x equals 9. So our volume is going to be pi, everything in terms of y. So it's going to go from 0 to 2. The large radius. The large radius is this one right here, because that's the furthest from the axis of revolution. So look at the furthest, it's going to be this curve, which is going to be y squared. Minus axis of revolution, which is a 9. Subtract. So this is a large radius. This is axis of revolution. Small radius is the first line you hit, which happens to be this one, which is 2y. Subtract axis of revolution. Actually, let me write down the next line. Okay, I missed space there. So simplifying this, that's going to be a y to the fourth minus 18y plus 81. That's going to be a 4y squared minus 36y plus 81. Distribute the negative. Nothing goes with the y to the fourth. That's going to be nothing goes with the y square. Actually, that's 18y squared, sorry. So those two, actually, that's negative 22y squared. Nothing goes with the 36. And nothing goes with the, oh, then the 81, that's a negative, and that's a positive, those cancel out. Antiderivative. Evaluating from 0 to 9. I'm only going to plug in the 9. I don't have to plug in the 0. And the answer comes out to be 296 over 15 pi. And that was page 4. Last one. I'm going to revolve it around the x equals negative 2 line now. Now the x equals negative 2 line happens to be right here. So if this is the axis of revolution, here's my curve. Here's my straight line. This is going to be another dy problem. This is going to be another dy problem. So here's going to hit this curve, and then it's going to hit this line right here. Now, the furthest distance is going to be the straight line. So this is going to be the large radius. And the small radius, the first line it hits is the curve. So this is going to be the small one. And because it's a dy problem, I need everything in y's. So the straight line happens to be the line x equals 2y. And the curve happens to be x equals y squared. This is a dy problem. Now it's going to be pi from 0 to 2, because that's the y-axis. The large radius, so the furthest is that line right there, the 2y line. Subtract the axis of revolution. The axis of revolution is a negative 2. So that right there is the axis of revolution. That was the large radius. Square, subtract. The small radius from here is going to be this one, which is going to be the y square. Subtract axis of revolution is a negative 2. Okay, the hard part's done. Now let's go and let's simplify this and do the antiderivative. So now here, that's going to be minus minus, which is a plus. So I have a 2y plus a 2 square. Here, once again, I have a plus. When I square it, this square is going to be a 4y squared plus 8y plus 4. This square is going to be a y to the 4th plus 4y squared plus 4. I'm going to distribute the negative and combine like terms. When I do that, nothing goes with the y to the 4th, so it's a negative y to the 4th. Next is the y squared. Those are going to cancel each other out because that's positive, that's negative. Next, I have the 8y. Nothing goes with the 8y. And then my single digits, 4 and 4, but that's going to be a negative 4, so those cancel out. Move on to the antiderivative now. The antiderivative, which that reduces to the number 4. And I'm evaluating from 0 to 2. I'm only going to plug in the 2. I don't need to plug in the 0. And it comes out to be a 48 over 5 pi. And that concludes our notes.